Yeah, thank you.
So I mean, like all the businesses, except some trader, will need some form of organization structure.
No, what is your topic?
Even in partnership, there is some
Everything
structure in the
is
partnership.
bonds.
So everything in the business, even if it's just two partners, need to know their role and responsibility. Okay. But for example, like there are two partners, right? So now, if we are two
Which
partners
type of
in
bond?
the business without
Metallic.
knowing each other,
Metallic bond. Okay.
responsibility, so it will create mess. So it means that the other than the sole tradership, uh, all business structure, including partnership, needs hierarchy.
So yesterday we studied about the covalent bond. Okay.
The important feature of organic structure and how these.
So can you define the covalent bond?
So
They're formed when like atoms share pairs of electrons to become stable.
is like having a like
Okay, good.
organization.
So how many types of covalent bond?
What you can
Um,
say that
two,
institution
no,
are
three.
different structure. For example, the organic structure is the formal and internal.
If I ask you what type of covalent bond is present in oxygen molecule?
Now,
Double.
the company, okay. So company is
Can you draw?
next like a structure, okay. So now for company,
Um,
we decide some rules,
yeah, I think.
regulation. We decide some like structure.
Okay, draw here.
So, however, like
Okay.
for that purpose, we formulate an organization structure. So, to formulate structure, we also establish some functional departments. What do you know about functional department? Actually, think that when your business become big or stand like
Okay, good.
new.
So how many number of bonded pair are present?
What happens in like
One.
small businesses?
One double
For
bond.
example, you are running a shop. Okay, so once you think that
One bonded pair will be in one bond, and one
like
pair of bonded electron will be here. So it means there will be two bonded electron pair
so you need some person
between
Okay.
two oxygen atom. So how many number of lone pair are present on one oxygen atom?
So I should hire a person. So you will hire
On one oxygen atom, there's two.
the department. And when you
Two. Okay.
sell me, so you give it by your like by yourself, by your finger. Clear?
Okay. So which type of bond is present in ethyne molecule?
So when like observing him, so you don't need to like another quality department because you are just looking by yourself. But once your business becomes very large,
Can you tell me?
expand. So you need
What did you say?
definition.
Which bond? Triple?
Like so when you are
I can't hear you.
I ask you, which type of bond is present in ethyne molecule? Like alkyne.
Is it triple bond?
And also it will fire and like terminate.
So there are some lone pair in ethyne molecule.
Solved by the HR department. Similarly, when you talk about the financial matter, so you will establish a finance department. And once you talk about the quality matters, you will quality control department. So all the matters.
How many bond electrons are present in ethyne?
So that is an organizational structure.
No.
So normally,
No.
like companies are perform the following tasks. It is marketing.
Can you count the number of covalent bond in ethyne?
These are like
Well, there's one triple bond.
One triple bond and two single bonds.
Okay.
So total number of bonded of covalent bond in ethyne will be 5. Okay.
Okay.
Okay. And now we discuss the metallic bond.
You will be managing quality control, operation, delivery, all the things that we manage.
What is metallic bond? Actually, metallic bond is only type of bonding that is present in metals.
Normally, the structure is followed by every department.
When we are discussing the bond in metals, we should know about the metals. What are the metals?
Then there's manager of department, then the subdivision, and like that.
So yesterday we were studying about periodic table.
Yeah.
So can you tell me the periods of periodic table in which elements of metals are present?
Number one, this structure of the company
The
is explaining about the
like 1, 2,
simple hierarchy structure. Very much simple.
3.
Why it's
In
simple?
which?
It contains
Period
Okay.
1, 2, and
Okay,
3.
I'm sharing with you periodic table.
That is a simple, no complex thing right here. Everyone knows. I will have, for example, I'm working in an organization company here.
This is a periodic table in which elements are arranged. Is it visible to you?
Yeah.
For the ship manager, there is a
I think it is not clear.
for the ship director, there is complete and director of a different ship.
It one for
And after that, there is an major director, and above that, there is CEO. And it is very much simple, like level of hierarchy, chain of command kind of. So, what is the level of hierarchy?
Is it visible to you?
Yes.
Okay, you can see in the first group, except hydrogen, remaining elements are metals. Lithium, sodium, potassium, rubidium, cesium, and francium. If we see in second groups, beryllium, magnesium, calcium, strontium, barium, and radium, this group is also contain metals. So first group elements except hydrogen are called alkali metal, and second group's elements are called alkaline earth metals. So if we see in the third group like aluminium, it is also metals. So this metallic bond is only present in metals. So we can discuss this metallic bonding in the metals. And one is the main feature of metal is that metal have the ability to lose electron.
Look at this organization, like different color are being mentioned.
Okay.
This is in brown, blue,
On which base we can say they can lose electrons?
and like pinkish and like blue, dark blue. Is it clear?
Why metals have the ability to lose electron?
Reduction implies are at the lowest level.
If we see like
Is at the top level.
we explain the example like sodium.
In larger organizations, as you move from the top to the bottom of the
So what is the atomic number of
there
sodium?
are people at each level.
Do you remember?
Because it is not possible for one person or a group
No.
of changing.
Atomic number of sodium is 11. This atomic number represents the number of proton and electron.
The task
So we are discussing about the bonding. So when we discussing about the bonding and electron are involved in the formation of bond. So electron present in sodium are 11.
For example, the accountant and the trainer.
If we draw their atomic structure,
Equal status.
like this is the nucleus. Nucleus contain proton and neutron.
So what is this actually? Why the hierarchy is get complex? Why there is more people on the same level? Because
And electron are present in the shell.
like production.
And there are 11 electron. First shell has 2 electron.
So the people in a certain.
And second shell has 8 electron.
It gets difficult for few people to control the overall business.
You can draw 8 electron in the form of pair.
And remember one more thing.
So we have put only 10 electrons. There are 11. So you will draw another
I'm working right now.
shell.
I have to report to my academic manager, for example. There are 5.
So this shell will contain only 1 electron. But 18 electron can accommodate in the third shell. but there is only one electron, so we will put only one electron in the third shell.
Academic
So you can see this electron that is present in the third shell, that is away from the nucleus.
all the academic manager have to report to the ship.
So we can say that distance between valence electron
Then the academic manager.
and nucleus is very far.
And
When the distance of valence electron is away from the nucleus, it's mean force of attraction between valence electron and nucleus is very weak. So that due to weak force of attraction on the valence electron, so valence electron can be released easily. That's why all metal have such like behavior. So all metal have the ability to lose valence electron. When they lose their electron, we can say it is a main property of metals. Okay.
which authority is
Okay.
passed down through an organization.
So when
Like what is the root?
metals lose electron, we can see
Why formulate the command?
C of electron.
Pass the order just to control the structure. Just to
Because from each atom of the metals,
so why,
electron are released.
why
We draw like a sodium structure for the metallic bond.
why like when the business start growing, example,
So this is the nucleus
like higher the more implies. It will not be possible
of one sodium atom,
at the top
and it is its electron. And this is the sodium nucleus of the second atom, and this is the electron. And this is the nucleus of another atom, and this is the valence electron. All atoms have the ability to lose electron. Likewise, this is the another sodium atom. It is its nucleus
for the ship
and its electron.
every teacher expected.
It is another atom,
Why?
and it is its electron that is released, that is lost by this sodium atom.
So
And this is another nucleus, another atom, and it is nucleus of that atom, and it lost this electron. So you can see there are number of valence electrons that are released by sodium atom.
and this is the reason.
So in such a way,
Chain of bond
in term of metallic bond,
contains
there is a sea of electron.
and it just lower down the hierarchy.
Collection of electron represent like a sea.
Chain bond describes the route through which authority is passed down to each manager from the top. Each person in the chain.
So this is the term of the metallic bond. So this metallic bond is only formed by the valence electron of metals.
them and directly responsible.
We can
for
say
the
this is
circularity.
the weakest bond in term of intermolecular forces. And there are two type of forces. One is intermolecular forces and second is intramolecular forces. Now we are discussing like ionic bond, covalent bond, and metallic bond. These have only intramolecular forces. These type of forces are present within the molecules. After discussing the intermolecular forces, we will explain the intramolecular forces at the end of this chapter.
Top management.
So this is the main characteristic of the metallic bond. So we can see their main characters for the loss of electron. I can say
I make feature while teaching and I don't
feature of metallic bond.
and any client just put the complaint in the complaint box that teacher is not giving me time.
Feature or characteristic of
So
metallic bond.
And the complaint reach in the table of the higher management. Then
First feature is this: metallic bond is only present by the loss of valence electron.
excellent. Why? Exactly, that is the thing. So this is the main point which is after it makes sure to like direct responsible. Each person in the chain of command that responsible for the person immediately above them and the record. So he is responsible for me and also responsible. And
If I give you main scenario of this,
so the accountant is the direct responsible for the finance directly. I'll give example. In a typical business situation, instructions are passed down the chain of command, whereas information about performance, for example, monthly.
we see in a proper way the definition. Metallic bond is a force attraction between floating valence electron. This is called CF electron, like this. This is called CF electron.
Now the third point.
CF electron, there is one electron and positively charged metal ion. When positively metal charge like this is formed, only when atom lost its electron. When atom lost its electron, it gets positive charge. So we can say it is a CF electron. Okay. So it works. Metal atom release some of their valence electron. These electron become delocalized. They cannot stop at one place. They can move from one place to another place, like water floating in the sea. So these electron also float in like a sea. So they are free to move through the metal. This is total metallic structure. They can freely move in the metallic lattice. The positively charged metal ions are held together in a lattice by electrostatic attraction. What is the electrostatic attraction? Uh, the force attraction between nucleus positive charge and valence electron, this is called electrostatic force of attraction. Is it clear?
Yeah.
So these are the three basic.
Okay, no, we have to discuss their characteristic properties of the metallic bonding.
You getting confusion here?
Properties due to metallic bonding. When metals have the ability to lose electron, so it means there will be the free of electron. So the free electron can move from one place to another place. It means they can conduct electricity. When we define the electricity, electricity is the flow of free charges in part during their time. So that's why metals are the good conductor of electricity. Okay. This is the
Okay.
main feature of metallic bonding. Second is the thermal conductivity. Electron transfer heat quickly through the lattice. Electron have the ability to take the heat from hot part and they can move to the cooler part where is low temperature. Through electron of the valence electron of the metals have the ability to conduct heat. That's why thermal conductivity is the main feature of the metallic bond. And third is the malleable and ductile. You can slide the layers of the metals. When you slide the layers of the metal, you can malleable the metals. You can convert it into the wires. You can make the wires from the metals. Aluminum wire and other wires. And copper wire, gold wire. Okay. So when these metal are converted into the sheets,
So
this property is called ductility.
okay. So now the
So you can malleable and ductile the metals without breaking the metallic bond. It means their metallic bond remain constant. That cannot be break down. And fourth main characteristic is luster. When you cut any metals, their free electron come out, they absorb the light and they reflect the light. That reflect light is appearance as a shiny surface. They appear like a shiny surface. We can say metals are luster. They have shiny appearance. This is the main characteristic of the metallic bond.
So there are different factors which
Metals have high melting point and boiling points. They can melt and boil at a high temperature because metallic bond is strong bond. It requires high energy to break that type of bond. It's mean metals have high melting point and boiling point.
If the task is complex and
If we explain the example like which elements have the metals,
authority, single person, to overlook
which metals have the metallic bond,
all the people. So then,
like copper, iron, aluminium, gold. If we see the periodic table
here,
like this first group element except hydrogen and second group elements have metallic bond, aluminium metallic bond, and this group, and these are called transition metals.
okay, for example, now we are having
These are called
examine manager, right?
transition metal. Transition metal have also metallic bond, like copper,
Newly hired or someone was old. Am I right?
silver, gold, zinc. So these are also metal. So when there is metal is present in periodic table, that metal must have the metallic bond because this is the complete metals. This is, we can say, it is the metallic lattice. This metallic lattice has its nucleus
Okay.
and free electron, valence electron. This is the metallic lattice. It has a nucleus and it is its valence electron. This is the nucleus of another atom and this is valence electron. This is the nucleus of another atom and this is the valence electron. So this is the complete lattice in which positive and negative charge are present. Positive charge is only nucleus and negative charge is the only valence electron. So force of attraction between valence electron and nucleus occur. This is called electrostatic force of attraction. Such a type of force of attraction due to charges, positive charge of the nucleus and negative charge of the valence electron. This type of bonding, this type of attraction is called electrostatic force of attraction. Is it clear?
Yeah.
Experience and different like expertise. So it means that due to that,
So we can say we can elaborate their metallic bond
will be highly
in some term of metals.
and keep them but lower in academic. But do you think that the span of control will be same of each manager? Excellent. This is the thing. If
This is the metallic bond. You are seeing this is a sea of electron. Every atom lost its electron. This atom lost this electron. So you can see this is the complete lattice. There is sea of electron.
And what happens? Like it creates problem. So
another example, if I elaborate with
the size of business, also an important factor for span of
this. And this is a metal when lost its electron. And this is metal, it lost this electron. This is the metal lost electron. These are the metallic ions. And these are the delocalized electron. When these electrons are lost from any metals, they can move from one place to another. They are freely. They can move freely. That's why metal are the good conductor of electricity due to free electron. Free electron can conduct electricity easily.
The level of hierarchy, the manager in the
top
structure will usually have
Okay.
span of control and the manager in the like.
So you can draw.
Organization structure are the like.
You can elaborate this more example like.
Management style, like some business use the management style that has a greater control over the workflow force than other.
You see here, this is a positive charge, that is a nucleus, and circular, this is an electron. This is the one layer. You can say they are present in, they have solid layers. This is another layer, and this is the third layer. So electrons are present near the nucleus because they are attached as a electrostatic. So these electrons can separate from the nucleus. They can move freely in the lattice. That's why this is their good conductor policy to conduct the electricity.
The range of span of control depends on the.
We can elaborate with another example like.
the size of the business, the management style, the like hierarchy structure, the experience skill, and the task and something like that. These factors.
This is the structure of sodium. There are 2 electrons in the first shell and 8 electrons in the valence shell. And this is the lost electron of the first. We draw this like
in the when the standard control will be high, it will
this. When it lost this electron,
for
its structure become like this. This is the atom with 10 electron and this electron is lost. So sodium gets positive charge. Then this sodium also lost this electron. This sodium lost this electron. This sodium lost this electron. So these electrons are separated from the atom. They can move easily in the crystal lattice of the metals. Now we discuss the metallic character in the periodic table.
Your voice is interrupting, Mike.
Now we try to explain their metallic character in the periodic table. This is the periodic table. When we move from top to bottom, when we are talking about from top to bottom, it's mean we are talking about the groups. In the groups, metallic character increases. Ability to lose electron increases. So it's mean if we say sodium is the least metal and francium is the highest metal. What is the reason? The electron present in the valence shell that is nearest to the nucleus in the lithium. But when we talk about the francium, there atomic number high, there will be huge electron. So extra shells are added, so valence electron is very, very far away from the nucleus. So when valence electron is very away from the nucleus, it's mean that has a weak force attraction with the nucleus that can be easily lost. That's why francium can lose easily electron. That's why metallic character of francium is high. When we talk about from top to bottom, metallic character increases. Likewise, this beryllium is less metallic and radium will be the highest. Okay.
Okay. So,
Yeah.
what you say?
So when we talk about in period from left to right in periodic table, you can see metallic character is decreasing because lithium is the metal, beryllium is the metal, but boron is metallite, carbon, nitrogen, oxygen, these are non-metal. It's been metallic character is decreasing in the periodic table. Okay. So these are the reason metallic character tendency of atom to lose electron and form positive ion. In group, a metallic character increases, atom get larger, outer electron are farther from the nucleus and more easily lost. Likewise, lithium to sodium and potassium. So potassium will be more metallic. Lithium, sodium, potassium. Potassium will be more metallic. It will have strong metallic bond. Okay.
Okay.
So when we talk about in period, metallic character decreases because atom have more proton. When we move from in the period, proton number increases, force of attraction increases, and they capture the valence electron. They cannot lose easily that valence electron. That's why they cannot conduct electricity. They cannot have metallic character. Example like sodium, magnesium, aluminum, silicon. See here, sodium, magnesium, aluminum, silicon. Sodium will have the highest metallic character, and silicon is a non-metal. It will has the lowest metallic character. Is it clear?
Yeah.
So any difficulty about this topic?
No.
Another topic of today or for your tomorrow? What is next topic?
Polymers.
And when you are not promoted,
Polymers. Okay, polymers we will discuss in next class, and we revise this lecture today again. Okay.
Yeah.
So metallic bond. Metallic bond is the type of bond which is present only in metals. Because metal has the ability to lose electron, that's why this metallic bond is present only in metal. When see it is the crystal lattice. Each crystal lattice there is many atoms. If I say this is the crystal lattice of sodium, so sodium nucleus has lost electron. This is the sodium atom, and this is its electron. This is the sodium ions, this is electron. This is the sodium ion, this is electron. You can see when an sodium loses its electron, then sodium gets positive charge. So this type of ions is present this. Okay? And this is the electron that is present this. Got this point?
Yeah.
So in complete lattice, all atoms have the ability to lose such type of electron and make a strong lattice. So this type of interaction, this type of connection of electron and sodium ions is called bond. That bond is called metallic bond because this bonding is present in metals. That's why it is called metallic bond. So then we saw in periodic table there are some metals. These are the transition metal. These are the alkali metal. These are the alkaline earth metal. So all metal have metallic bond. So this is the definition of metallic bond.
But on the contrary,
It is a force attraction between free floating valence electron and positively charged. Metal atoms release some of their electron. These electrons become delocalized. Delocalized means they cannot stop at one place. They can move from one place to another place. The positively charged metal ions, these positively charged metal ions held together with electron. This is called electrostatic attraction. This is present between this sodium ions and valence electron. So this is the properties of metallic bond. Metals have electrical conductivity. They are good conductor of electricity due to presence of free electrons. Free electron can move easily from one place to another place. They can conduct electricity easily. Second property is the thermal conductivity. Electron transfer heat quickly through the lattice. And third is that they are malleable and ductile. And they are present in the layers. And you can slide one layer to another layer. And without breaking the bond, you can convert metal into wires and sheets. Like you have seen the boxes of the metals that are formed with the process of ductility. Second, the luster. When you cut any metal, then you can see shiny appearance on the metals. This shiny appearance is due to presence of a valence electron.
So
This electron absorb energy from sun.
what will be now? What do you prefer again?
When it absorb energy from sun, then it reflect.
Dull or
That reflect is appear in the form of shiny surface. Example of metal with metallic bond. Metallic bond is present copper, iron, aluminium, and gold. And this is the complete metallic bond of free electron. This is a sodium with a 10 electron, and this is the 11th electron that is released from the sodium. So these are the free electron. These can make C of the electron.
now?
Then I explained with you another example.
Is
You can see it.
vector- What do you mean by like a delirium? Did you study it?
And this is the metal line, and they are free electron.
Okay.
These are also an delocalized electron.
Now what you say? You are going in.
These
hired as a
metal
CEO,
ions are present in a crystal lattice.
and you see that-
They are present in orientation. They are arranged in a particular way.
that what you-
When you slide their layers, they convert it into another form, like voids, like sheets.
so
But
what
their metal bond remained constant. Metal bond didn't break. Metal bond fixed these positive and negative electrons.
I'm repeating again. For example, you are hired as a CEO in an organization.
So this is a lecture of about metallic
the
bond,
organization
and then this is the
uh,
trend of metallic character. From top to bottom in the groups, metallic character increases due to atom get larger size and valence electron farther away from the nucleus that can be easily lost. Example, lithium, sodium, and potassium. You can see lithium, sodium, potassium. So potassium will have maximum metallic character and metallic bond. And we see in period from left to right,
Excellent. Definitely you
metallic character decreases.
Bharati or the
Because when you move from left to right, proton number increases. When proton number increases, it captures the valence electron. It strongly held together with the valence electron. So valence electron can not be released easily. That's why metallic character decreases. Metallic character increases where electron can be easily released. From top to bottom, lower elements can release valence electron easily. That's why lower elements have highest metallic character. When you move from left to right, these elements are non-metal. Non-metal have the ability to gain electron. That's why non-metal cannot become metals, because their characteristic is only to capture the valence electron. That's why non-metal never be metals. That's why metallic character decreases from left to right in the periodic table. Is it clear?
Yeah.
Okay, I am sending you the lecture of picture in the chat.
Yeah, now I can hear you. Okay. It was one concept. It might possible that they may ask in MCQs only. It's not detailed like concept. So just you need to know the delayering mean. For example, if they ask you in MCQ, so you need to know that okay, delayering mean that reducing the layer of organization. Just don't need to go in detail. Okay. Yeah. Okay. So did you understand which I explained you?
Checkbox, have you received the lecture of today?
No.
Check your
Oh, yeah.
box. You have got? Okay.
Yeah, don't worry. I will.
So, Mamna, do you have any query or question about this?
No.
No?
No.
Okay, Momna, you have to revise and prepare it, and I will ask some question from this tomorrow, and then we start next topic after this. Okay?
That is HR, human
Okay.
resource.
Okay, beta, take care.
We discussed
Allah Hafiz.
department in
Allah Hafiz.
organization. One of the department was HR. Yeah.